Assalamu alaikum, sir.
Walaikum assalam.
How are you, sir?
Alhamdulillah. Okay, so topic is about nuclear reactions. And in this chapter, like during different topic, we talk about fission, fusion, reaction indirectly. We talk about the examples of atom bomb and the reaction uh, that takes place on the sun. So in nuclear reaction, there are two type of reaction we need to study. The first one is called nuclear fission reaction. Second is called nuclear fusion reaction. So the first reaction is fission reaction. Okay, basically in fission reaction, fission and fusion both are opposite to each other. So in fission reaction, just like you consider if we take a nucleus that is equals to the mass of the football, for example. So if we have a nucleus that is equals to the mass of the football, and if we cut down that football into like small parts into the size of the tennis ball, right? So if we combine four or five tennis ball, let's suppose, so that will be equals to the total size of the football, right? So in the same way, in fission reaction, what happens? We split a large nucleus into small nuclei, but those small nuclei are more stable as compared to the large one. Okay, so this process is called fission reaction. Because we know we are talking about radioactivity, and in this chapter of radioactivity, we discussed that radioactivity is the process that takes place in unstable nuclei or unstable nucleus, and due to that instability, nuclear starts to emit out radiation. So that's why in fission reaction, when we split a large nucleus that is unstable into smaller, more stable nuclei, so that is called fission reaction. So definition and the concept is very simple. Nuclear reaction in which large, unstable nucleus breaks into smaller, more stable nuclei, and also large amount of energy released during this reaction. So another quantity is the quantity of energy. Okay. But this reaction is not like a natural, right? Because we are splitting up a large nucleus into smaller nuclei. So this reaction is not naturally happens. to start this reaction, we need to trigger or we need to insert a neutron in the unstable nucleus, right? So one more thing in this reaction, this is the basic definition. And to start this reaction, this reaction is triggered by inserting a neutron in the unstable nucleus. Any idea why we are adding up like extra neutron in the reaction? Why not proton? Why not electron? And why only neutron? And if neutron, so why only neutron? We are like inserting neutron in the nucleus because that is already unstable. So basically, the reason is we know that neutron is neutral, right? So there is no charge on it. It is neutral, so it will be easy like for the neutron to move. Because if we use positive charge, if we use negative charge, so we know in the atom electrons are revolving around the nucleus. So if we strike electrons, so electron is smaller in mass and it also repels by the electron in the surrounding. And for example, if we strike proton, so proton is heavy and proton is a positive charged particle and that can be repelled by the nucleus. So these are some reasons that we are using neutron. And to start this reaction, we required a neutron to make it more unstable. Okay. And let's suppose if you want to like consider the practical example that uh, how we perform this fission reaction. So these fission reactions can be performed in a nuclear power plant, but just like the example of the atomic bomb. So in atomic bomb, the same procedure is followed to start that reaction. So for example, if we consider a video clip to understand the concept, and it is not like to strike a single neutron because it is not compulsory that you strike a single neutron and that single neutron directly strikes the nucleus. Maybe that misses the nucleus. So we strike so many neutrons in a single time. So one of the neutron strikes the nucleus. So we will see that how it actually works. Okay. So as we already know that the atom bomb experiment or what we ever say is taken place in Hiroshima. And we only need to study that how this reaction actually starts and how it actually works. And we know that how much energy is going to be released from this reaction. And that because of radioactivity, we studied about half-life, we study about that radioactivity or the radioactive particles are very harmful because those radiations can damage cell and the human body. But if that radiation remains in the atmosphere for so long, for so many years, so definitely those radiations can damage uh, the new generation also and the human body whenever those radiations are in the atmosphere. So in this documentary we can see, like it is like when you drop a bomb that contains the atom bomb actually. So this reaction, we need to start this reaction, okay? Because if we directly drop that bomb, and that bomb will not blast even it strikes the ground, so we need to trigger this reaction. So in this video you can see there is a short like type of animation included. So basically this is neutron, right? When we turn on it, so you can see this green signal shows you that now they are going to strike neutron, and that neutron is going to strike the nucleus. So you can see when it strikes the nucleus, so the atom becomes more unstable, right? And due to instability, that nucleus will not able to like balance it, and it starts to explode. So this is the simple working of this fission reaction, okay? And this fission reaction is like a chain reaction. You observe in the video also, when it strikes the nucleus, so it becomes unstable, and you can see more neutrons are striking the other particles also. And they are starting like chain reaction, one explosion, second, third, fourth, fifth, like this. So it is also like a chain reaction. Once we just trigger this experiment, or we trigger this reaction, so it will continue to turn on, and it will continue to split up the particles into the smaller nuclei one by one. So it is like a chain reaction. So first of all, if we write down the nuclear equation for it, because we studied about alpha decay, beta decay. So in this process, we are actually striking up a neutron. So let's suppose if we write down the equation, so we can easily write down the equation. We know that we have to balance that equation on both sides. So initially we are taking, let's suppose uranium, because uranium is unstable nucleus and it is more unstable. Uranium 92, 235. So initially we have uranium, and this uranium is large unstable nucleus. And the second thing is we need to start this reaction by inserting a neutron. So we need to add neutron in the reaction. So this is neutron, right? So 0 means 0 number of proton, 1 means 1 number of neutron only. So when we add these two elements, so in result we will get, according to the definition, a large unstable nucleus breaks into smaller, more stable nuclei, right? So it splits it up into smaller nuclei. So those smaller nuclei will be like any element. In our chapter, we don't need to remember any name, any element, because equations are already given in your question, and you need to complete that equation only by balancing the number of protons and number of nucleons. So let's suppose in this reaction we got one element, barium, which is 56 and 140. So you can see this element is smaller than uranium. And we got another element which is krypton, 36, 93. Plus, now let's check this equation. Equation is balanced or not? Because you got the number of protons, you got number of neutrons. So if you like check your equation, that both sides are balanced or not. The equation is balanced.
Sir?
Yes.
I want to ask that after like adding the uranium and one neutron,
Hmm.
wha- where did the element Ba come from?
Okay. Basically, initially we have uranium and neutron, right? So if we add them, so after their addition, we got total number of proton, which is 92. 92 proton and 235 plus 1, 236. 236 number of nucleons, right? Like proton plus neutron. Okay.
Okay.
So now try to check that either equation is balanced or not as compared to the final components that we get in the result.
So sir, having 92
Hmm.
electrons and 236 nucleon,
Hmm.
um, how do we get Ba? Like the element Ba with 140 nucleon number and
Okay, basically just that part is you don't need to remember the name of the elements. Just consider that this reaction is normal, right? Whenever we add neutron in the uranium element, so it splits into Ba barium element and Kr krypton element. Okay. So we don't need to
okay.
memorize these elements, right? The name of the elements, their numbers, their atomic mass, atomic number. You just need to check that your equation is balanced or not. So initially we have 92 number of protons and 236 number of nucleons on the top. So we just need to check on right hand side either these numbers are balanced or not. So on right hand side we need to check by adding up the numbers of these two elements. So if we talk about number of protons, so number of protons will be 56 plus 36. It is 92. It means number of protons are balanced, right? Initially we have 92, finally we have 92. But if we talk about the number of nucleons on the top, so 140 plus 93, it is equals to 233. So it means equation is not balanced, right? Because we have three less number of nucleons as compared to the initial stage. So what we
Okay,
need to
sir, P is standing.
Means proton.
P. Okay.
P
What
represents
about electron?
proton.
Sir, but what about electron? Like, proton part isn't it being covered in the nucleon part, 236
Basically,
nucleon?
yes, we know that the number of protons and electrons are always same in the nucleus
Yes.
we studied. So if we have 92 protons, so definitely there will be 92 electrons, right? And if we talk about
Okay, sir.
n,
Okay.
yes, this n represents not neutrons. These n represents number of nucleons. And if you remember, nucleon means proton plus neutron, right? So this
Yes,
is the
sir.
combined number of proton and neutron. So it means we have three less number of nucleons as compared to the initial stage. So we need to cover that, right? So just like in the video you observe, when we started up the reaction and after the reaction starts, it continues to, like you can see, one strike, two, three, four, and these collisions continue automatically, right? We only strike one neutron into the nucleus, and then we observe in the video that some other particles are also striking the other nucleus. So what are those particles? Actually those are neutrons, because when we strike neutron into the nucleus and it splits into the smaller nuclei, so it also emits neutron, right? And those neutrons automatically strikes the other nucleus or the other remaining part of the nucleus, and this reaction continues. Okay. So this equation can be completed by adding up 3 more neutrons. Okay. So now you can see 233 plus 3, because 233 represents the number of nucleons, and number of nucleons are addition of protons and neutrons. So if we add 3 more neutrons, so it becomes 236 number of nucleons. So now you can see both sides are balanced. Okay. In the same way, if we consider another equation, just to practice it. So for
Sir,
hmm,
I want to ask that this part,
yes,
this is the this is the symbol of that we are adding
yes, neutron.
neutron,
Yes, the trigger
and
neutron.
then okay, and in the after adding in the
Mhm.
after the krypton, what we are adding three is representing that we have added three neutrons.
Yes, basically those 3 neutrons are the neutrons that we are getting in the result, right? So initially we have
Okay,
reactants. Actually, these elements are called reactants, because these two elements are reacting with each other, right? Just like in chemistry, you studied about reactions. So these two elements are actually called reactant. Like you are mixing up these two things and you are getting something new. And finally, this is your product, right? So you are adding up uranium and neutron. So these are reactants, and in final product, in final result, you are getting this whole part of the right side of the equation. Okay. So this is your product. You are not adding up this in your experiment. You only add neutron with uranium, and in final result, you are getting these three elements: Ba, barium, Kr, krypton, and neutron. Okay. In the same way, if we
okay,
consider, yes, one more equation. So let's suppose there is another possibility. Just like we studied in the start, that it is not compulsory that one nucleus can only emit alpha, it can only emit beta. There are multiple possibilities, right? So another possibility for uranium is like this. If we consider again uranium 92 with 235 number of nucleons, and again we add up one neutron in it. So in final results, you will get different elements also. Now you can see the numbers are different. We got one element with 54 atomic number and 144 atomic mass. So you can see now the numbers are different as compared to the first equation. And from periodic table, you can check these elements. You will get the name of the element easily, but that is not compulsory in physics, because in physics there is no concept of periodic table. You don't need to learn periodic table. And we got another element, 38 number of protons and with 90 number of nucleons. So now you can see both equations are completely different. So again, let's check this equation, that this equation is balanced or not. So initially we have same 92 proton and 235 nucleons. So you can see we are taking up, okay, this is 230. Okay, just a second. Yes, right. 236. So again, we have 236 nucleons and 92 protons. So again, check this equation. that in product, are you getting the same number of protons or and nucleons or not?
So what do we check?
In this equation, just like the previous one, in previous equation,
Yes,
we
sir.
check that equation is balanced or not, right? So is this equation
Okay.
is balanced or not? So you need to check the number of protons and nucleons.
Okay. I'll be adding 154 and 90.
144 and 90, yes.
Yes. Sir, it's giving me the answer 234.
234. So it means now we have 234 nucleons. And what about the number of protons? Number of protons are balanced. So number of protons are balanced, right? So number of protons are balanced, but again, the number of nucleons are not balanced. So we need to balance them. So we have 234. Initially, we have 236, just like the previous equation. Initially, we have 92 proton and 236 nucleons, right? So still we have two nucleons less as compared to the equation. So what we need to add in final result, we need to add two neutrons this time, okay? Because we have two less number of nucleons as compared to the reactants. So when we add two more neutrons in your equation, so your equation will be balanced, right? 234 plus 2, 236, right? Any confusion? Because in your exam, let's suppose if they ask about this reaction, so they will not ask about complete equation. They will not ask to write complete equation or to write the name of the missing element. Only they ask about the numbers, right? So you just need to check that your numbers are balanced or not. If they are balanced, so that's good. If they are not balanced, so you need to balance those numbers. Okay, so name of elements are not important, only the numbers are important. Okay.
Sir, I have a question.
Mhm.
Sir, it's written in uranium. It's like 235, but
Yes,
when you wrote on the bottom there, you said there's 236 neutrons.
yes, basically in uranium we have 235 nucleons, right? And in nucleons we studied that nucleons consist of proton plus neutron, right? So if we are adding up additional proton, if we are adding up additional neutron, so that will increase your number of nucleons, right? That is called mass number also, right? So 235 plus we have one more neutron, right? So 235 plus this number of neutron. So 235 plus 1 equals to 236. So in this way we are getting 236. Okay?
Okay, sir.
Yes. Because on the top we always write number of nucleons or mass number, and in nucleons we have proton plus neutron, so there is a combination of it. Okay,
Okay,
so
sir, now I understand.
right, so this is the same thing just like the balancing equation, and the reason in the start we discussed why we are using neutron only, right? So because we have electron proton also, so why only neutron? So this is also a question in exam. If they ask why we use neutron only, So reason is very simple. First of all, if we talk about proton, so proton is already a positively charged particle. Proton is positively charged. So proton would feel repulsion. And why repulsion? Because nucleus is already positively charged, right? We discussed in the Rutherford experiment that the nucleus is positively charged. So that's why if we strike a positive charge particle, so definitely a positive charge particle feels repulsion. And to insert that proton, we required high energy because it is just like combining two elements which are exactly trying to oppose each other. So that's why it is difficult and more energy will be needed. And if we consider electron, so in electron, the problem is that electron is small in size and that electron is not enough to create more instability, right? Because we add neutron to increase uh, more instability, right? So electron is very small to create enough instability, right? So if they ask why we only use neutron, because there are other options available also. So why we choose neutron only? So this is the reason to choose neutron, because neutron is neutral, right? There is no charge on neutron, but on proton we have positive charge, and there is a problem with positive charge that it feel repulsion because of the nucleus. Nucleus is already positive. And the second thing is, if we talk about electron, so the problem with electron is that electron is small in size, and that's why it is not enough to create instability in the nucleus, right? And it is like a chain reaction. For example, if we write the if we discuss we write these two equations. So from these two equations, if you want to draw a diagram, so you will get like a chain reaction. For example, we have uranium. This is uranium, and a small neutron strikes this uranium, and in result you will get multiple elements, like you will get another neutron, and before that we got two different elements. We got element X, let's suppose, we got element Y, and we got another neutron. And now these neutrons are going to strike the nucleus continuously, because the nucleus is still there. It is unstable, but nucleus is still present over there. So it continues to strike with the nucleus again and again, right? Because nucleus is very heavy part. You can see it is of 236 nucleon number. So nucleus will not explode in a single time. It takes a long time interval to decay completely. So this reaction continues to go on. So you can see this is like a chain reaction. We are getting new and new elements again and again. Again, new elements. We are not writing the name, we are writing XY. And in the same way, from this, we are also getting neutron. Okay.
Okay.